Uh, Now we are considering a layout. An appender uses a layout to format a log event into a form that meets the need of whatever will be consuming the log event. In Log4j 1.x and logback layouts were expected to transform an event into a string. In Log4j, two layouts return a byte array. This allows the result of the layout to be useful in many more types of appenders. However, this means you need to configure most layouts within a charset to ensure the byte array contains correct values. Here you can see Log4j layout. The layout component specified in the format in which the Log4j in with the log classes, log statement are written into the destination repository by the appender. In Log4j we have different types of layout implementation classes. Here the class layout in repository Log4j. Extend this abstract class to create your own layout format. Class date layout, repository Log4j helpers here in version 1.x. This abstract layout takes care of all the date related options and formatting work. Class HTML layout in repository Log4j. This layout outputs event in HTML table. Appenders using this layout should have their encoding set to UTF-8 or UTF-16. Otherwise, event containing non-ASCII characters could result in corrupted log files. Pattern layout, class pattern layout, a flexible layout configurable with pattern string. This code is known to have synchronization and other issues which are not present in Log4j layout to enhanced pattern layout. Enhanced pattern layout should be used in preference to pattern layout. Enhanced pattern layout is distributed in the Log4j extras companion. This is about Log4j 1.x. Class simple layout. Simple layout consists of level of log statement followed by dash with the and then the log message itself. For example, debug space dash space hello world. XML layout, class XML layout. The output of the XML layout consists of series of Log4j event elements defined in the Log4j.dtd. It does not output a complete well-formatted XML file. The output is designed to be included as an external entity in a separate file to form a correct XML file. Here the layout has direct nouns subclasses here. Date layout, HTML layout, generate logs in HTML format, pattern layout, simple layout, and XML layout, generate logs in XML format. Here you can see Log4j 2 layouts. Log4j 2 layout class here, and the layout component specify the format in which the log statement are written into destination repository by appender. In Log4j 2 we have different types of layout implementation classes. Class sorry the interface layout converts log event instances into different layouts of data. The layout typically encodes into either string or byte array. Since version 2.6, layout implement encoder type parameter log event to support direct encoding of a log event to a byte buffer destination without creating a temporary intermediary objects. Since the version 3.0.0, the layout no longer refers to legacy Java serialization API and are limited to strings or bytes. Class pattern layout, a flexible layout configurable with pattern string. Class HTML layout, output events as rows in an HTML table on an HTML page. YAML layout, append a series of YAML events as string serialized as bytes. XML class XML layout, append a series of event elements defined in log4j.dtt. Class JSON layout. Not the JSON layout should be considered as deprecated. Please use JSON template layout instead. Append a series of JSON events as string serialization as bytes. So the Log4j 2 has implementing classes pattern layout, HTML layout, YAML layout, XML layout, and JSON layout. This is about Log4j 2 layouts. Now we are considering layout object hierarchy in Log4j 1.x. The structure of logging information can vary in terms of message content, the type of content, and the way information is presented. But in abstract terms, the logging information can be organized into a header, body, and a footer. A header may present in an introduction to the message. Body contains logging information, and the footer contains footer section can contain some hint about content of the message. You can see how this resembles in physical documents that people deal with every day. Bearing this idea in mind, Log4j provides an abstract class called layout that offers skeleton implementation in all the command operations. In other, individual layout objects are basically subtypes of that abstract superclass. The individual layout objects differ in styles, and they use to format the logging information passed to them. These individual layouts objects inherit all command operations from their abstract superclass and implement their own formatting methods. They may override and provide their own implementation of any method in the base class. This figure depicts the class diagram of different layout within the Log4j API. This is Log4j 1.x. The class layout extend this abstract class to create your own layout format, and class simple layout. A simple layout consists of the level of log statement followed by dash and then log message itself. Class pattern layout, a flexible layout configurable with pattern string. This Code is known to have synchronization and other issues which are not present in Log4j to enhance pattern layout. The enhanced pattern layout should be used in preference to pattern layout. Enhanced pattern layout is distributed in the Log4j extras campaign. This is about Log4j 1.x. Date layout. This abstract layout takes care of all the date related options and formatting work. The class TTCC layout. TTCC layout formats consist of time, thread, and category, and nested diagnosis context information, hence the name. HTML layout. This layout outputs events in HTML table. Appends using this layout should have their own encoding set to UTF-8 or UTF-16. Otherwise, events containing non-ASCII characters could result in corrupted log event. This is about Log4j 1.x. And XML layout. The output of the XML layout consists of series of Log4j event element defined in the Log4j.dtt. It does not output a complete well formatted XML file. The output is designed to be included in an external entity in a separate file to form a correct XML file. So layout class has subclasses here in Log4j 1.x: simple layout, pattern layout, date layout, XML layout, and HTML layout and XML layout. Date layout has a subclass TTCC layout here in Log4j 1.x. Here you can see an HTML file produced with HTML layout in Log4j 1.x here. Interface layout textend serializable lays out a log event in different formats. Formats are byte array and implementer of serializable like byte array, string, log event. Since 2.6, layout can encode a log event directly to a byte buffer destination without creating temporarily intermediary objects. This is in package org.apache.login.log4j.core. Here you can see the component builder new layout method, layout component builder, new layout, string, plugin name. This returns a builder for creating layouts, and the attribute key and value is here, and it is added to the appender builder. Here the class pattern layout, a flexible layout configurable with pattern string. The method public static pattern layout create default layout configuration creates a pattern layout with using the default options and given configuration. These options include UTF-8, the default conversion pattern, exceptions being written and with NC escape codes. This is this class is in the package org.apache.login.log4j.core.layout, and here the layout is passed to the method create appender here. Here CSV layouts. This layout creates a comma separated value CSV records and required Apache common CSV. And the method debug here, string message and object. Here the parameter to the message, one parameter to the message, two parameter to the message, message 0, 1, 2 here. Um, the CSV layout can be used in two ways. First, using CSV parameter layout to log event parameters to create custom database, usually to a logger, and file append uniquely configured for this purpose. Secondly, using CSV log event layout to log events to create a database and as an alternative to using full DBMS or using JDBC driver that supports the CSV file. The CSV parameter layout converts an events parameter into a CSV record, ignoring message. Logging as a CSV events look like this here. This produces a CSV record with the following field: the time nanos, and time millis, and level, thread ID, thread name, thread priority, and formatted message, and the logger FQCN, and logger name and marker, thrown proxy source, source, and context map and context stack. And additional runtime dependencies are required for using CSV layouts. You can as an example file, you can consider as here to send a Greylog 2.x server with UDP. Guelph layout lays out events in Greylog extended log format, Guelph 1.1. This layout compresses JSON to gzip and zlib. The compression type: if a log event data is larger than 1024 bytes, the compressed threshold. This layout does not implement chunking. Here the parameter name host string and the value of the host property optional default to local hostname. Here this is the one. And compression type can be a gzip, lib, or off. Compression to use optional default to gzip. Here zlib. And compression threshold, this is integer, and compressed if data is larger than this number of bytes, optional default to 1024. As an example, C configure as follows to use data pattern and time zone. HTML layout generate HTML page and adds each log event to a row in a table. So here date pattern, parameter name, and this type string, and the date format for logging event. The default is JVM underscore elapse underscore time, which output the milliseconds since JVM is started. This is here this is ISO 8601. And time zone, this is string and the time zone ID of the logging event. Here you can see JSON layout appends a series of JSON events as a string serialized as bytes. Here a pattern layout, a flexible layout configurable with the pattern string. The goal of this class is to format log event and return the result, format of the result depending on the conversion pattern. Here this example shows how to filter out classes from unimportant packages in stack traces. The conversion pattern is closely related to the conversion pattern of the printf function in C. A conversion pattern is composed of literal text and format control expressions called conversion specifiers. Each conversion specifier starts with the percentage sign and followed by optional format modifiers and conversion character. The conversion character specifies the type of the data category, for example, category, priority, date, name. The format modifiers control such things as field width, padding left, right justification. Here the pattern, the parameter name pattern is a string, a composite pattern string of one or more conversation patterns from the table here. Patterns cannot be specified within a pattern selector. Here the m percentage sign of m output the message, output the application supplied message associated with the logging event. This $sign xex, same as the $sign throwable conversion word, but also include class packaging information. Here percentage n outputs the platform dependent line separator character or characters. As an example 9, we are considering XML layout appends a series of event element as defined in the log4j.dtd. This is to include any custom field in the output. Use this syntax. In YAML layout appends a series of YAML events as strings serialized as bytes. To include custom fields in the output, you can use this syntax here. Here you can see a JSON layout appends a series of JSON event as a string serialized as byte. Here you can see the log events follows this pattern in JSON. With XML layout appends a series of event element as defined in the log4j.dtd. Well-formed XML document follows this pattern. With YAML layout appends a series of YAML events as strings serialized as bytes. A YAML log event follows this pattern. Now we are considering the package log4j.login.log4j.core.layout in module log4j.login.log4j.core. Log4j 2 layout support The layout plugins should use the configurable plugin namespace annotation with an element type of layout. Now we are considering layouts. The root class for the layout that use the charset is ogda.login log4j coded layout abstract string layout, where the default is UTF-8. Each layout that extend abstract string layout can provide its own default. The class abstract string layout in package ogda.login coded layout in module ogda.login core abstract base class for layout that results a string. The appender uses a layout to formulate a log event into a form that meets the needs of whatever will be consuming in the log event. In Log4j 1.x and logback layouts were expected to transform an event into a string. Log4j 2 layout return a byte array. This allows a string of the layout should be useful in many more types of appender. However, this means you need to configure more layout with the charset to ensure that byte array contains correct values. The root class for layout that use charset is ogda.login log4j coded layout.abstract string layout, where default is UTF-8. Each layout extend abstract string layout can provide its own default. The custom character encoder was added to Log4j 2.4.1 for ISO 889-1 US ASCII chart to bring some of the performance improvement built into Java 8 to Java Log4j for use on Java 7. For application that log only ISO 889-591 character specifying this chart set will improve performance significantly. CSV layouts in layout. To log CSV records, you can use the usual logger method info, debug, and so on. As of Log4j 2.11.0 CSV support has moved from existing module Log4j-core to new module Log4j-CSV. This layout creates a comma separated value CSV records required Apache Commons CSV 1.4. CSV layout can be used in two ways. First, using CSV parameter layout to log event parameters to create custom database, usually to logger and file appender equally configured for this purpose. Second, using CSV event layout to log event to create a database as an alternative using JDBC or using JDBC driver that support the CSV format. The CSV parameter layout converts the event parameters into CSV record, ignoring the message. The to log CSV record, you can use the logger methods info, debug, and so on here, which will create a CSV record like here. Alternatively, you can use object array message, which only carries parameters. Layout CSV parameter layout and CSV log event layout are configured with can be configured. Logging as CSV events look like this. Produces CSV record with the following field: time nanos, time millis, level, thread ID, thread name, thread priority, formatted message, logger FQC and logger name, marker, thrown proxy source, and context map and context stack. Additional runtime dependencies are required for using CSV layouts. GLF layout. GLF layout configured as follows to send the gray log 2.x server with UDP. The class GLF layout in package log4j.log4j.core.layout in module log4j.log4j.core lays out event in a gray log extended log format GLF 1.1 here. Logs out event in a gray log extended log format GLF 1.1. This layout compresses JSON to gzip or zlib. The compression type if log event data is larger than 1024 bytes, the compression threshold. This layout does not implement chunking. Configuration as follows to send the Greylog 2.x server with UDP. Configure as follows to send Greylog 2.x server with TCP. Here you can see the UDP and here TCP. Gray layout parameters host string, then the value of the host property optional, default to localhost name. Compression type gzip, zlib and off. Compression to use optional, default to gzip. Compression threshold int, compress if data is larger than this number of byte, optional, default to 1024. Include null delimiter boolean, whether to include null byte as an delimiter after each event, optional, default to false, useful for Greylog Gelf TCP input, cannot be used with compression. Include thread context boolean, whether to include thread context as additional field, optional, default to true. Thread context includes string, comma separated list of thread context attribute to include when the formatting event. This attribute only applies when the include thread context is true as specified. If the thread context exclude are specified, this attribute will override them. Thread context fields specified here that have no value will be omitted. Message pattern string, the parameter to use the pattern to use to format the string. Message pattern and pattern selector cannot be both specified. If the both are present in the message, the pattern will be ignored and the error will be logged. If not supplied, only the text derived from the logging message will be used. To include the custom field in the output, use the following syntax. The custom fields are included in order they are declared. The values support lookups. Now we are considering HTML layout. The configure as follows to use the date pattern and times on in HTML layout. The class HTML layout in package log4j.login.log4j.co.layout in module log4j.login.log4j.co output events as rows in HTML table on an HTML page. HTML layout parameters, date pattern, string, date format. For logging event, the default is JVM underscore elapsed underscore time, which output the millisecond since JVM is started. Time zone string, time zone ID of the logging event. If not specified, this layout uses java.reload time zone.get default as default time zone. Like date pattern of the pattern layout, you can use the time zone ID from java.reload time zone.get time zone. Configure as follows to use the date pattern and time zone in HTML layout. Now we are considering JSON layout, the complete well-formatted JSON versus fragmented JSON. The log event follows this pattern. If you configure complete equal true, the append outputs will output a well-formatted JSON form JSON document. By default, the complete equal false. You should include the output as an external file in a separate file to form a well-formatted JSON document. If complete equal false, the appender will not write the JSON open array character open square bracket at the start of the document and close open array bracket at the end of the document, no comma between records. The log event follows this pattern. If a complete equal false, the appender does not write JSON of open array character open square bracket at the start of the document and closing square bracket and the end and no comma between records. Now we are considering JSON template layout in combination with below the Log4j configuration. The JSON template layout is a customizable, efficient, and garbage-free JSON emitting layout. It encodes log events in accordance with the structure described by the JSON template provided. For instance, given the following JSON template modeling of the official logstash JSON event layout version 1 here. In combination with below Log4j configuration, the JSON template layout will render JSON for document as follows. Now we are considering pattern layout, example patterns in pattern layout, the filtered throwables here. This example shows how to filter out classes from unimportant packages in stack traces. The result printed to the console will appear similar to here. Class pattern layout in package login.log4j.login.log4j.co.layout in module log4j.login.log4j.co. A flexible layout configurable with pattern string. A flexible layout configurable with pattern string. Goal of this class is to format log event and returns the result. The format of the result depends on the conversion pattern. The conversion pattern is closely related to the conversion pattern of the printf function in C. The conversion pattern is composed of literal text and formatted control expressions are called conversion specifiers. Note that any literal including special characters may be included in the conversion pattern. Special characters include /t, /n, /r, /f, and use // to insert a single backslash into the output. Each conversion specifier start with a specific with the percentage sign and is followed by optional format modifiers and a conversion character. Conversion character specifies the type of the data, for example, category, priority date, thread name. The format modifiers control such things as field width, padding, left, right, justification. Here the output message m output applied message associated with the logging event. Here the ex the name the same as the $ throwable conversion word, but also include a class packaging information. Now we are considering the class considering RFC 5424 layout. Here the class RFC 5424 layout in package log4j.login.log4j.co.layout in module log4j.login.log4j.co formats the log event in accordance with RFC 5424. This is the parameter name, app name, type string, description, the value to use in as the app dash name in the RFC 5424 syslog log. As the name implies, the RFC 5024 layout formats the log event in accordance with RFC 5424 enhanced syslog specification. Although the specification primarily directed at sending messages via syslog, this format is quite useful for other purposes since items are passed in the message as self-describing key value pairs. Serialized layout. The serialized layout simply serializes the log event into a byte array using a Java serialization. The serialized layout accepts no parameters. This layout is deprecated since version 2.9. Java serialization has inherent security weakness. Using this layout is no longer recommended. As an alternative layout containing the same information is JSON layout configured with properties equal true. Now we are considering sys layout, class syslog layout in package log.apache.login.log4j.co.layout in module log.apache.login.log4j.co formats a log event as BSD log4j code. This is a parameter name charset, type string. The character to use when converting the syslog string to a byte array. The string must be a valued charset. It's not specified. This value uses UTF-8. The syslog formats the log event in as BSD syslog record, matching the same format used by Log4j 1.2. Now we are considering complete well-formatted XML versus fragmented XML in XML layout. A well-formatted XML follows this pattern. Append a XML layout append series of event elements as described in log4j.dtd. If you configure complete equal true, the append outputs well-formatted XML document where the default namespace is log4j namespace. HTTP here the login.apache.log4j 2.0 events. By default, the complete equal false, you should include the output as an external entity in the separate file to form a well-formatted XML document in which the in case use append the namespace prefix with the default log4j. A well-formatted XML document follows this pattern. If the complete equal false, the appender does not write the XML processing instruction to the root element. To include custom with regarding pretty versus compact XML, to include custom field in output, use the following syntax. Custom fields always last in the order they are declared. The values support lookups. Additional runtime dependencies are required for using XML layout. Now we are considering YAML layout. YAML log event follows this pattern. Appends a series of YAML events as string serialized as bytes. A YAML log event follows this pattern. To include any custom field in the output, use the following syntax. The custom fields are always last in the order they are declared. The value support lookups. Additional runtime dependencies are required for using YAML. Now we are considering location information. If one of the layout is configured with the location related attribute like HTML location info, or one of the patterns %C or %class, %f or %file, %l or %location, %l or %line, %m or %method, Log4j will take snapshot of that stack and walk the stack trace to find location information. The method HTML layout.builder set location boolean location info in class HTML layout.builder in package log.login.log4j.co.layout in module log.login.log4j.co. This is an expensive operation, 1.3 to 1.5 times slower for synchronous loggers. Synchronous loggers wait as long as possible before they take this stack snapshot. If no location is required, the snapshot will never be taken. However, synchronous loggers need to make this decision before passing a log message to another thread. The location information will be lost after that point. The performance impact of taking a stack trace snapshot is even higher for asynchronous loggers. Loggers with location is 30 to 100 times slower than without location. For this reason, asynchronous loggers and asynchronous appenders do not include location information by default. You can override the default behavior in your logger for asynchronous appender configuration by specifying include location equal true. Now we are considering layouts in Log4j2 compatibility with Log4j1, HTML layout, pattern layout, simple layout, TTCC layout, XML layout. Now we are considering supported Guelph layout in supported layouts in configuration in garbage free steady state logging. Guelph layout is garbage free when used with compression type equal off, as long as no additional fields containing $sign then variable substitution. Now we are considering extending Log4j3 layouts in extending Log4j3. The plugin can alternatively use plugin builder notation The class abstract string layout in package log4j coded layout in module log4j.log4j.co abstract base class for layout that result in string. Layout perform the formatting of events into printable text that is written by the appenders in some destination. All layout must implement layout interface. Layouts that format the event in a string should extend abstract string layout, which will take care of converting string to a required byte array. Each layout must declare itself as a plugin using @plugin annotation and configurable annotation with the element type of layout. The print object should be set to true if the plugin toString method provide a representation of the object and its parameters. The name of the plugin must match the value the value user should use to specify it as an element in their appender configuration. The plugin must also provide the static method annotated with the plugin factory and with each of the method parameters annotated with the @plugin attribute or @plugin element as appropriate. The plugin alternatively use the plugin build annotation. Handle Boolean parameters. Example occurred in the environment with AnyPoint Studio. We can consider this could not create plugin of type class org.apache.login.log4j.core.layout.pattern layout for element pattern layout, java.land.nullPoint exception, etc. As an error example, we can consider this occurred in the environment Oracle Data Integrator version 12.2.1.4.0 to 12.1.2.1.4.2006-18. javaland.no class def found error, org.apache.log4j.layout error when executing ODI to LC mapping using Hyperion S-base KM. This is end of my presentation. Thank you very much for watching.